Welcome back to another YouTube video. Today we're going to be going over the same skill as the last video, which covered both the medium and foundational difficulty level. We're going to be going over the advanced difficulty level of this same skill. Before we get into it, make sure to subscribe and let's get started. So whenever we see graphs and linear equations, what I like to do is immediately convert into y equals mx plus b format. So here we have a system of inequalities. We're just going to convert from standard form to y equals mx plus b format. The whole point of this is to just isolate the y variable. So let's do that. We move over the x in that first inequality. So it changes to a negative x. And then we just divide both sides by -2. Remember, when we divide by negative, our inequality sign switches. So it goes from -2y is greater than or equal to y is less than or equal to 1/2 x. Moving on to our second inequality here, same thing. We're just going to isolate the y. We move over the x. So now we have 2y is less than or equal to -x plus 4. Now we divide everything in the inequality by +2. We don't need to switch any signs here. Y is less than or equal to -1/2 x plus 2. So these are our two inequalities here, and we're just going to see which of them matches. We should be shading below each of these inequalities in order to find our correct answer. So let's take a look at answer choice A. We can see here that we are shading above this line, so it's automatically going to be incorrect. With answer choice B, we're shading above on both lines. With answer choice C, we are shading above on this bottom line right here. And then answer choice D, we are shading below on both lines. That is equivalent to our less than or equal to inequality sign, meaning that answer choice D is correct. Moving to question number 2, the graph of the line in the coordinate plane passes through the points 2, 3 and 4, 6. Graph of the second line has a slope of 6 and contains the point 1, 15. The two lines intersect at point A, B. What is the value of A times B? So here, let's just follow a linear progression of creating our equations first, then solving that systems of equations, and then multiplying our x and y coordinate together to find our answer. So first, let's just create the linear equation of this first line. When given two coordinate pairs, we can indeed do this. We just need to do y2 minus y1 over x2 minus x1. y2 is 6, y1 is 3, x2 is 4. So we do 6 minus 3, that's 3. 4 minus 2 is 2. Our slope for that first line is 3/2. And we also need to find our y-intercept. How we do this, we take a coordinate pair, we substitute in 3 for y and 2 for x. Once we isolate the b, we find our y-intercept. So 3/2 times 2 is just 3. And then to isolate the b, we just subtract 3 on both sides, which cancels out to 0, meaning this equation has a y-intercept of 0. So our full equation is just y equals 3/2 x for that first line. Now for our second line, we need to use point-slope form because they give us a slope and they give us a point. So our point-slope form is y minus y1. So y minus 15 equals m, which is our slope, times x minus x1. Now we just need to get this into our y equals mx plus b format, of course. So we distribute that 6. Then we add 15 to both sides. -6 plus 15 is 9. So then we are left with y equals 6x plus 9. And y equals 3/2 x for our two equations. Now we need to find where the two lines intersect, otherwise solve our systems of equations. Here, since the y's are both isolated, we can just set both of the equations equal to each other. If you're a little bit confused here, I'll recommend a playlist where we solve these systems of equations. So that will be in the top right of the screen. So we set them equal to each other. 3/2 x equals 6x plus 9. Now we can subtract 6x from both sides. 3/2 minus 6 over 1. We need our common denominator, so it's going to be minus 12 over 2. 3 minus 12 is -9. So then we have -9/2 x on our equals 9. So -9/2 x equals 9. In order to isolate our x variable, we need to multiply by the reciprocal fraction, which is -2/9. So we're going to multiply each side by -2/9, cancels out on our left side. 9 times -2/9 is just -2. So our x value equals -2, and in order to find our y value, we just substitute it into an equation. Let's just substitute it into our first equation. We just need to do 3/2 times -2, which is equal to -3. So our x value equals -2, our y value equals -3. Otherwise, our a is -2, our b is -3. A times b is +6. So answer choice B is our correct answer choice here. Moving on to our third question. In the coordinate plane, if the solutions to the systems of the inequalities y is less than ax plus 1 and y is greater than bx plus 1 are only in quadrant 1, which of the following relationships between a and b must be true? Here, let's just kind of graph out each of our lines, because our solutions can only be in quadrant 1. They have the same y-intercept, but we don't know, is a negative number, is a positive number? All we know is that it's less than a. So let's say something like this is our a line, and we're going to be shading less than. And then our b line is greater than. So if the solutions were to only be in quadrant 1, and our b line was greater than, we can see that here is a great example, because our solutions are just within this little sector here, which of course is in quadrant 1, meaning that based off of this, our a value is greater than our b value, and they are both positive. So let's check that here. Our a value is greater than our b value, and they are both greater than 0, meaning they are both positive. This matches to our demonstration graph, meaning that answer choice C is correct here. So whenever we are given abstract terms such as variables, and we're given a scenario and a diagram, feel free to use that diagram to help you figure out the answer. To question number 4 here, we have, of course, two linear inequalities here, and we need to find which quadrant contains no solution or otherwise has no shading. No overlapping shading inside of it. So what I would like to do here is create a coordinate grid. That way we can accurately graph both of these inequalities and accurately shade, so we can know, which of these 3 quadrants has the double shading in it and which quadrant does not have any. So that way we can find our answer quite easily. Here, let's construct our coordinate grid. So this coordinate grid is not perfect, of course, but it is good enough to graph both of our linear inequalities accurately. Let's start with our first one. We're going to start at -4, and we are going to be going up 3 to the left ones, graphing that -3 slope. So it looks like that for our first point. So that's our first linear inequality. It's going to be a straight line, and we're going to be shading below. So let's portray that as well. Now let's graph that second inequality. Our second inequality has a y-intercept at +8 at our very top here, and then to go to the left, we're going to go down 3 across 1 once again a solid line. We're going to shade below this line as well. Hopefully you guys can see where our solution set is located, as it is located in this triangle right here. That is the solution to the systems of inequalities. And as we can see, we have solutions in quadrant 2, we have solutions in quadrant 3, we have solutions in quadrant 4. However, there are no solutions in quadrant 1, meaning that quadrant 1 is the answer to this question. It contains no solutions to the systems of inequalities. Even though this method took a little bit longer, it avoids any little mistakes where if we just tried to graph roughly, we might not see that this sector, for example, that the solution is in quadrant 2 or in quadrant 4. It's very small parts of our solution set is actually within those quadrants. That is all for today's lesson. I hope that you guys enjoyed this advanced difficulty, as these questions were quite hard. In the following videos, we will be going over unit tests that review all of the information that we have done so far. And I look forward to seeing you guys then. Goodbye!